So this has been a frustrating week, but worth it. I spent this week setting up my IsaacSim desktop. I chose to go with used parts and I found a good provider. And the reason I did that is so that he'll allow me to swap out and upgrade parts as I need to without having to buy new stuff and having to commit to exactly what hardware I need now without actually knowing exactly what kind of workloads are going to put what stresses on the components down the line. So this way I've started off with what I think is a decent spec, but I can upgrade and not lose money each way along the way. So this is what I landed up getting in the end. I got an i5 14600KF as my CPU. I put in 32 gigs of RAM. I got an RTX 3080 with 10 gigs of RAM. And I did have the option of getting much higher CPU, more RAM, a 3090 or a 4080, and I was even offered an A6000 with 48 gigs of VRAM. But what I wanted to do is start on a lower spec and then see where I struggle and then upgrade as and when I need to. And I think that'll help others on the channel know what to buy and know sort of what is the minimum spec that'll get you going. And then we'll see where those bottlenecks go and then I'll upgrade as I go along. But I managed to put all of that together for $1,200 and I decided to go with Ubuntu over Windows according to ChatGPT. That will give the smoothest experience, especially with ROS integration. And I must say it is a night and day difference running locally and not going through EC2 that was driving me mad, and it's just so beautifully smooth. And I also set up NoMachine on my Mac so that if I don't want to be sitting at the desktop, I can work from anywhere in the house, or I can go to a coffee shop and I can go straight into my machine. I'll show you a little example of a NoMachine working. And then if you want to see what the new machine looks like, here we go. There's the RTX 3080 and filled with all sorts of RGB, which I didn't think I would like, but I actually really like, and then went ahead and got the matching keyboard with all the RGB in as well. And now for the tutorial today, we're going to be importing a URDF file and creating some example robots that came with IsaacSim. All right, let's jump right in. And as promised, this is how I'm connecting with NoMachine. So I've already pre-configured the setup here. I just double click OK, and there is my Ubuntu desktop. And it's not quite as fast as sitting right in front of it, but it's pretty close. I can pan around much better than the EC2, and then I can be anywhere in my house and connect. And there, as you can see, the specs I mentioned, my CPU, i5 14600KF, 32 gigs of RAM. I've got a tough gaming motherboard, and my graphics card here is the GeForce RTX 3080, and I've got 10 gigs of RAM there. So before we import the URDF file, let's go ahead and see where we're going to find it and open it up and have a look at the typical file structure of a URDF file. So we're going to go to our IsaacSim folder and we're going to go to ext cache, and then this URDF asset importer URDF folder, data, URDF, robots, and then there's Carter, and we will go to URDF, and then you'll see the URDF file. Now let's right click that and open that with a text editor, and let's have a look at what we see here. And we can see the top level XML structure starts off with robot, and then we've got links, and links are the actual physical objects, and as opposed to the joints that connect the individual items. And we can see we've got a link called the chassis, a link called the left wheel, and let's see if we can find a joint. Yeah, there we go. Joint, fixed, continuous. And you'll see what those are when we actually import the robot. And then every one of these objects or links has got a little bit of extra information, like its visual information, its geometry. It's also got collision information as well. And for the joints, we've got what type of access it has, and the parent and the child. Now we're going to take that URDF file and import it into IsaacSim. It used to be up here under Isaac Utils workflows, but now it's just simpler. You just go straight to File, Import, and we're going to navigate to that file we looked at a little bit earlier, Carter, URDF, and then select the URDF file, and we've got the options coming up on the right. And we're going to change a couple of options. Now Carter is a two-wheeled mobile robot, and it's got a third passive wheel at the back and two other wheels on the side. So we don't want to have a static base. We're going to make it a movable base. And then for the left wheel, we're going to change that to velocity, right wheel velocity, and we're going to set both the rear axle and the rear pivot to none, and we can go ahead and import. And then we can see there's our Carter robot. Now we're going to go to Create, Environments, Flat Grid, and now we have a ground plane. Let's move Carter a little bit above so its wheels are resting on the ground plane. So let's select Carter and pull it up on its Z-axis. There we go. One other thing we can do, you can see it's given us a default light. We can turn that on or off depending on how we want to work with our robot. I prefer it turned off, so I'm going to leave it off with this dark blue grid. And now let's see if physics is working correctly. And if we lift Carter up, let's see if gravity brings it back down to the ground plane. So let's move Carter up. Oh, I moved the ground plane by mistake. Let's select Carter, move Carter about 1 meter in the air, and then let's push play, and we can see, yes, gravity is being applied. Now let's look at the hierarchy of elements and joints within Carter. So you can see we've got the left wheel link, rear pivot link, rear wheel link, and right wheel link. So let's zoom in a bit and inspect each of those. So I think the left wheel and right wheel are pretty obvious visually, but let's rotate around and let's see the rear pivot link and rear wheel link. So here is the pivot, and this is the one that is basically on the Z-axis that works like a shopping cart trolley, and the rear wheel link is the one that just works off the Y-axis and rotates forward. But obviously this rear pivot link and wheel link do not have any actual drive. It just rotates around as the force of both the left wheel and the right wheel are driving it forward. This will just be pulled along from behind. Now let's inspect the joints. So if we look at the left wheel joint, we can see some of its properties. We can see body 0 is the chassis link, the main chassis, and it is connected to body 2 via this joint, which is the left wheel link. So body 0 and 1 will always just show what is between the joint, and we'll see it'll be the same for the right wheel, except instead of the chassis link and the left wheel, it'll be the chassis link and the right wheel. And we will see the axis of the revolute joint for both the right wheel and the left wheel will be the Y-axis, and we can see here there's the Y-axis going across that. But if we look at the rear pivot, obviously the axis of that will be the Z-axis because it is facing up. Let's zoom in a little bit. If we click on the rear pivot, it is a vertical axis with this bolt sort of coming from top to bottom. And then if we see the rear axle, that'll obviously be rotating forward, and that is going to be also along the Y-axis. So let's make Carter move. So I'm going to zoom out a bit so we can see it moving, and let's go to our left wheel joint, scroll down a bit, and under target velocity, let's just set the value like 10, and we're going to do the same with the right wheel, target velocity 10, and let's push the play button, and let's see, Carter should now move. There we go, moving. And if we want Carter to go faster, let's change it to 100. There we go, going a lot faster. And you can also multiple select. You can also do a multiple select. So we can click left wheel, control right wheel, and then set target velocity at the same time. If we want Carter to move in a circle, then we can just adjust one wheel to be moving and the other not. So let's select just the left wheel, and let's just change that target velocity to 0, and let's see what happens. As we expect, it goes around in a circle. One thing we will have to adjust, as you can see under the chassis link here, we've got that as our articulation route, but we actually want our top level object, Carter, to be the articulation route. So we're going to remove this articulation route, and we're going to go to Carter, add physics articulation route. Now it's in the right place. And one thing we have to do is we want to uncheck self collisions enabled. We're going to add a differential controller to Carter like we've done in one of the earlier videos. So for that, we select Carter and go to Tools, Robotics, OmniGraph Controllers, differential controller. Then we're going to select the robot prim, which is Carter. Select. Now we need to determine the wheel radius. Let me show you how you're going to find that. Find that value, you can select either the left or the right wheel link. So let's go to the left wheel link and we go to collisions, mesh, and cylinder. And you can see on the cylinder mesh, we can see a radius of 0.24. So we can enter that in. Then for the distance between wheels, we can again select the left wheel link and we go down to transform and we see on the y-axis it's 0.31. So we can see this is the y-axis going along the axis that the wheels are running, and it's 0.31 away from the center, which means we just need to double that amount, which will make it 0.62. So it's obviously 0.31 away from the center in both directions. Now we have to enter in the right and left joint name like we have in a previous video. And we do want the keyboard control and we click OK. Now let's press run and use our keyboard. So there's the W, and the S, the A, and the D. But you can see that is going really, really quickly. So let's limit that a little bit. Let's go to graphs, differential controller, and differential controller again. And let's limit the max wheel speed to 2 and the max linear speed to 2. And we can see now if we run, this is W, S, A, and D. That's a little bit more manageable. Now, although we imported a URDF file, once we save it in IsaacSim, it saves in the default USD format, and this is binary, but there is also a text-based version, which is USDA. But I'm going to do a series of videos of that soon, where we go into the USD format and go into quite a bit of detail. So just wanted to mention that. One other thing I wanted to point out is there are some templates here, robot templates. And if you go ahead and add a new Nova Carter with sensors, so that's like the file we just imported, but it's got a lot more sensors. We'll see what it creates for us. And we can see here's the Nova Carter robot. We've got a lot of detail under the chassis link, for example, the sensors. We've got over 10 different sensors here, left, right camera, and if we go into perspective, we can actually see all the cameras. So we can look camera right, camera left, LiDAR, etc. And if we go ahead and create an ant, we see we've got this cool ant-like robot. And if we go ahead and we lift it up and we press play, we can see it lands standing up. And let's create our Boston Dynamics spot. And let's push play. Here's the humanoid. So I just wanted to point out these example robots here. Haven't had time to really go through them and see each of the joints and each of the elements, but I'm guessing there's probably a tutorial out there for each of them and how to get them configured and actually running. And if I can find those, I'll do a video on each of those. Thanks so much for watching, and if you enjoyed this video, please consider liking or subscribing, and I will see you in the next one. Adios.